if our salary function is $3,000 times e to the 0.03t, then we can do quite a bit with this. Okay, so let's see what we can do. In the first place, we can take the derivative of our salary function. Okay, so we can do ds dt, where s again is a salary function as we have here, and we see easily that derivative is 3,000 times the derivative of e to the 0.03t, 3,000 being a constant. The constant rule says it's going to be that constant times the derivative of the changing function, the e to the 0.03t. And that derivative is the derivative of the 0.03t, which is 0.03, multiplied by e to the 0.03t. An application of the chain rule and the fact that the derivative of, say, e to the x with respect to x is just e to the x. Now, we might be a little bit rusty on rules for derivatives, but it's a fairly straightforward derivative. And we will be spending some time reviewing derivatives of exponential and logarithmic functions. People had an idea, but again, there's a little rust because not everybody completed. It's been a while since some people completed the course, the first semester. Okay, now I'm going to let this big fancy capital S function be, that's 100,000. Now I originally had 100 because my brain wasn't working right, but it's 100,000. You can't see necessarily all the zeros unless you look closely, times e to the 0.03t. And if we take the derivative of this, well, it's very similar to what we did when we take the derivative of this. We get 100,000. I still don't think I have enough zeros in there. Okay, so let's just make it 1 and make that into a 0. There's a 1 and a 0. It looks really bad, but there it is. Okay. Our derivative of e to the 0.03t is still 0.03 e to the 0.03t. And we multiply that by the 100,000, we get 3,000 e to the 0.03t, and that's our original function. So this big fancy s function is a function whose derivative is the s function, and the s function in turn has its derivative. Okay, so what I say up here now is s being the derivative of the big fancy s function, then the big fancy s is what we call an antiderivative of s. Now, there, along with this, we have the fundamental theorem of calculus. We have an illustration of how this all works, and we can build on this for the rest of the semester. It turns out that the actual area under the curve 3,000 e to the 0.03t between 2 points is the change in the value of the antiderivative function between those points, as you'll see in the homework. So to give you a little bit more to go on, there are some questions in the homework that ask you to build some trapezoidal graphs based on this function. So we're going to continue with that in a minute.